All right, so in Algebra 3, this is our lesson on section 6.2. Like we did in the previous lesson, we simplified, multiplied, and divided rational functions, rational expressions. We're going to add and subtract rational expressions. So there are two different types of rational expressions that we're going to look at. Ones that we add or subtract together that have like denominators, and then some that do not have like denominators or unlike denominators is what the term is. So let's look at these. Okay, well, before looking at this example right here, I'm going to show you real quick, remind you of how to add fractions together. Now, whenever we add together, say something like 1/4 plus 5/4, we want these denominators to be the same. If they are not the same, then we have to get a common denominator. But since they are the same, the denominators do not change. It stays as 4. And then we just add together the numerators. So we would have 6. And then the same thing goes with subtraction. If I did the same thing here, like 1/4, let's do 5/4 minus 1/4. Again, subtraction is the same. You want your denominators to be the same, and then you put together the numerators. So 5 minus 1 gives you 4, which reduces to 1, and then this actually reduced to, let's see, 3/2. Okay, so that's how we're going to do these rational expressions is the same way as we have done fractions, or adding together and subtracting together fractions in the past. All right, so let's look at that real quick. All right, we have this example here. It just states add. We're going to add together these two expressions, and they do have like denominators. See here, here's one denominator. Here's the other. They both have the same factors, so they're both the same. Since they are both the same, what we're going to do is, all right, sorry I got interrupted. I don't know exactly where I left off my last sentence, but what we're going to do in the first step is just write a single denominator, because these are like denominators. Just going to write 1. And then we're going to combine together the two numerators. So we're going to say x squared minus 81x minus 1, then plus whatever symbol's here goes here, 3x minus 5. And now we just add together and subtract together the like terms that are in the numerator, and we are done. So we can keep the x squared as x squared, and then 81, negative 81 plus 3x, let's see, 81, let's see, that's 78x, and then minus 1 and minus 5 come together as minus 6, and then just rewrite that denominator. We do not necessarily have to multiply or FOIL this denominator out. After we've combined the numerators, we are done. I guess another step would be at this point to simplify. If we can simplify any further, then do that. If not, then don't worry about it. A way that we could simplify this expression is by factoring what's in the numerator and then canceling any common factors out between the numerator and denominator, as we did in the previous section. But since this numerator is not factorable, then we don't have to worry about that. We are done right here. All right, so for this example, it's similar to the last one, except it says subtract. And in subtraction, whenever we have like denominators, we do it just as we did with the addition. Put everything over the same denominator and then combine together the numerators. But with subtraction, you got to be careful. So we're going to say x minus this entire numerator right here. So that negative sign is going, or that minus sign is going to distribute to all of the values in this numerator. So I'm going to go ahead and do that process. I'm going to say minus x squared minus 2x plus 6. And then after we're done combining together the like terms, then we're going to factor. So this right here is equal to negative x squared minus just x, because x minus 2x is x, and then plus 6. And that's still all over x plus 3. Now, we're going to factor. I'm going to take out a negative first from all of this. So we get x squared plus x minus 6, basically changing all the signs. And now factor what's inside the parentheses here. And that factors to x plus 3, x minus 2. And so now in this one, we are able to simplify a little further. So we can cancel out the x plus 3's, and we are left with either you can write it as minus or a negative x minus 2, or you can write it as negative x plus 2. I'll accept either one of these answers. All right, let's move on. All right, so now we're going to do a couple of examples that deal with unlike denominators. And just like in adding, subtracting fractions that have unlike denominators, we kind of go through the same steps here. So we need to determine the LCD, write each fraction as its equivalent fraction with the LCD, then add or subtract the numerators while maintaining that same LCD, so keeping the denominator the same. We don't add or subtract anything in the denominator when combining in addition and subtraction of the numerators. And then last step, like we did in the previous example, when possible, factor the remaining numerator and factor the numerator and sometimes even the denominator and simplify the fraction. Okay, so I'm going to show you just a simple fraction one. I'm going to say let's do 3 over 2 plus 1/4. Okay, since these denominators are not the same, we have to get a common denominator. And the way we get a common denominator is, well, this is 4, it's bigger than 2. Well, what do we need to multiply to 2 to make it 4? And the answer is 2. So what we multiply to the denominator, we must multiply to the numerator. So what we're doing here is we're going to say 3 over 2 times 2 over 2 okay, and then 3 times, then we do multiplication of fractions like we did in the previous section. So 3 times 2 straight across and 2 times 2. So 6 over 4 plus 1/4. Now we have the same denominator that stays the same, and combine the numerators by the symbol you have in between. So 6 plus 1, 7/4. So it's going to be a lot like adding and subtracting fractions, but we have values of x's in our um, fractions that we have here, our rational expressions. Okay, let's look at the example then. All right, so here we have it the 3 over w plus 2 plus 5 over w. This right here, and then this right here are two totally different things, two totally different denominators. And we can't just simply say add 2 here, add 2 here. Nope. We got to multiply both numerator and denominator to get our common denominators to be able to add these rational expressions together. So this right here, we just need to multiply this by a factor of w and this one by a factor of w plus 2. And whenever we do, whatever we do to the denominator, we have to do to the numerator. Sorry, try to get those words out correctly. So what we're going to do is we're going to say 3 over w plus 2 times w over w plus our 5 over w times w plus 2 over w plus 2. Now we need to multiply straight across, and there is no need to distribute or FOIL any of the factors in the denominator. We can just keep it in factored form, but go ahead and do that with the numerators. Go ahead and distribute or FOIL this out. So we're going to distribute that 5 to both of these. Okay, so 3 times w, multiplying straight across, 3 times w, get 3w over w times w plus 2 plus, and then I'm going to say distribute that 5. It's 5w plus 10 all over, now, the same denominator, w times w plus 2. And now that we have the same denominator, I'm going to write it as this denominator right there. And we're going to combine the numerators, the 3w plus 5w plus 10. The 3w plus 5w gives us 8w, and then plus 10. Now the last step is factoring the numerator. And this thing factors to, let's see, the only common factor between 8 and 10 are 2. That's it. So we're left with 4w. Oops. Or w plus 10. No, plus 5. Over I'm just making a bunch of mistakes. And at this point, the factoring didn't really show us that we have common factors in the numerator and denominator to cancel out, so we can just keep our final solution as that, and we're done. All right, so we're going to do the same thing in this one. You're going to say we have this is a factor in this denominator, and this is its own factor in this denominator. Now we got to multiply both numerator and denominator to get common denominators. Usually this is pretty much the way it goes every single time. This first rational expression that we're subtracting from the other, we're just going to multiply by both numerator and denominator by the denominator of the second rational expression, so 3x. Then minus, now kind of do the same thing, but with the other rational expression. We have going to multiply it by both numerator and denominator of this value right here, 4x plus 4. Okay. Now that we have same denominator, once we multiply straight across, let's go ahead and do that. We get 3x squared here over 3x times 4x plus, that's supposed to be plus. No, it's supposed to be minus. How about that? Okay, minus 4. And then minus. Now this is going to stay the same, just minus. And then 1, it's going to be the same. 1 times 4x minus 4 is just 4x minus 4. All over the 3x times 4x minus 4. Now combine together the numerators, so 3x squared minus 4x minus 4. Remember, we're going to distribute that negative across. So we're going to get 3x squared minus 4x plus 4. And the denominator stays the same. And then the last step would be to see if this factors at all. And I don't really think it does. Let me think about this. See, it actually does factor, but the factors aren't going to cancel out with anything in the denominator. But just to show you, the numerator does factor out to x minus 3 and 3x plus 2. So yeah, none of these factors actually cancel out with each other. You can either leave it as this solution here, or you can leave it as its unfactored solution right here. All right, so here's our last example. All of these pretty much follow the same exact steps. This one, whenever we're finding the common denominator, it differs just slightly. And the reason it differs is just because in this denominator, we need to go ahead and factor it first before trying to find a common denominator between the two of these rational expressions. So let's go ahead and factor it out. I'm going to go ahead and state the x plus 3 and the x squared minus 3x minus 10. Let's see, that factors out to x minus 5 and x plus 2. And then I'm going to kind of skip a little bit so we can do the next step here. Oops. Okay, so same thing as above. I just rewrote the denominator in its factored form. And in its factored form, we can see that we have in common between the two denominators an x minus 5 already. What we do not have in common is the x plus 2. So what we need to do is add or multiply both numerator and denominator of this one. Don't know why I wrote it out so far. So multiply this numerator denominator on the second expression by x plus 2 and x plus 2. All right, I'm going to go ahead and put that in parentheses. So now multiply is the next step. The two numerators, the 2 times the x plus 2. And then let's see, we get, I'm going to go ahead and distribute that across. So I get 2x plus 4 over the same denominator, x plus 5 times x plus 2. Sorry, minus. Don't know why I keep trying to keep adding plus signs instead of minus signs. There we go. Now, combined, now that we have different, or the same, sorry, not different, but same denominators, keep the denominator the same and combine the numerators. There we go again. Let's see, x minus 5 and x plus 5. Sorry, x plus 2. And then remember, this negative sign is going to distribute across these numbers right here. So get x plus 3 minus 2x minus 4. Okay, now we're going to combine together these values here in the numerator. So x and minus 2x, negative x, and the 3 and minus 4, minus 1. Sorry if this is so hard to read. And that's over x minus 5, x plus 2. And nothing in the numerator and denominator will cancel out. This can factor out to a negative x plus 1. But still, those factors aren't going to cancel out with anything in the denominator. So we can just keep our solution as this right here. And we are done. So key thing in all of these sections so far, first section and this one, is being able to factor and multiply, definitely, and then be able to simplify like you have in the previous section. So watch this intently, rewatch it if you have to, and then start on your homework. And I'll see you in class. Goodbye, everybody.